1.59 from Precalculus OpenStax. Pretty challenging problem, which is why I wanted to make sure that I did it. What's going on here is you're not starting with one of the functions from your toolkit as your starting spot. You're instead starting with this graph right here, and you're told that this is the graph of f of t equals 2 to the t power. That'll be really important. That'll be an important graph when we get into exponential functions, which will lead us into logarithmic functions, which is something you're probably not doing in this class if you're taking a Precalculus 1 class, but when you get to Precalculus 2, you will be very interested in this kind of stuff. At any rate, here's a function. And if you take as a given that you know that the graph of this thing looks like this, the question becomes, can you graph k of t, is the name that they're giving this thing, negative 2 raised up to the negative t power plus 1. There's actually 3 different transformations going on in this problem, which makes it really challenging. This plus 1 right here, I'm not adding 1 to the input, the value t right here. I'm adding 1 to the output, to the 2 to the t power. So this right here is a vertical shift. In other words, I'm going to add 1 to all y values. This negative right here, you can think of as negative 1 times this function. So this, in my notation, is a vertical stretch. Although most books wouldn't call it a stretch, so maybe this has to be in quotation marks. They'd call it a reflection. But I prefer to think reflections don't even exist. They're all just stretches. All I'm doing here is I am multiplying all y values by negative 1. So really, I don't even care if you call it a stretch or a reflection or whatever the hell you want. Just know that the way you apply it, at least using my methods, is you're going to multiply all the old y values by negative 1. Another thing to notice is I have 2 different vertical transformations. It's really important that the order that I apply these transformations. You got to do the multiplication ones before you do the addition ones. Everything vertical is nice. It follows your intuition, and you think that you should multiply before you add, and in fact you do. And we're still not done. I don't know, I'm kind of running out of colors here. I guess I'll go back to red. There's this negative 1 right here. Unlike this negative 1, this negative I'm multiplying the f of x, or f of t in this case, by. In this case, I'm not multiplying the entire function. I'm not multiplying the output. I'm multiplying the input, the t value, by negative 1. So this is a horizontal stretch. And again, your book, and many books, will refer to this as a reflection, and they'll make it sound like it's some brand new type of transformation. But I don't like thinking about there's 6 or 8 different types of reflections. I like saying there's only 4. And I'm just saying it's just this one right here, where I divide whatever number I'm multiplying the x, or t in this case, by. I take all the old x coordinates and I divide them by that number. Well, all I have is negative t, so that number is negative 1. So I'm going to take all the old x coordinates and divide them by negative 1. I'm going to divide x coordinates by negative 1. And the nice thing is that's my only horizontal transformation, so the order that I apply it makes no difference. I don't need a number by it. I can do it first, I can do it after this one, I can do it after I do both of these. It makes no difference. It's totally up to me when I apply it. I'll end up with the same answer no matter what. Okay, so let's try applying a couple of these. I think I'm going to apply these in steps. I think I'm going to first apply my vertical transformations and kind of get an intermediate graph, and then apply my horizontal transformation to get my final graph. So let's pick some points right here. Unfortunately, there's not too many points that fall at integer values here. I have one at 0, 1, and I have one at 2, 4. And then down here, it's kind of hard to see what the heights are. I have one at negative 4 that has some height that's close to 0. It's really hard to tell what that height is actually equal to. It turns out it's 1/16. But really just note that I have some height that's damn near 0, but the x-coordinate is negative 4. And let's apply these vertical transformations. I'm going to apply this one first and then apply this one. So this one, I'm going to take all the old y values and multiply them by negative 1. So maybe I'll start with this point. This y value was 1. If I multiply it by negative 1, it goes down to negative 1, because 1 times negative 1 is negative 1. And then if I add 1 to all of the y values, so I've multiplied it by negative 1 that brought it down here, then I add 1, it ends up right here. This point is going to go down to here. What about this point that used to have a height of 4? Well, 4 times negative 1 is negative 4, but then I'm not done. I have to add 1, so that brings me back up to negative 3. What about this guy here that was damn near 0, some really small positive number? Well, when I multiply it by -1, it's still damn near 0. It's just some really small negative number. Now I'm going to add 1 to it, so that'll bring me up to almost 1, not quite, right around there. And those, I think, are enough points for me to sketch this graph, which is not the answer. Maybe I'm calling this k, let's call this like g of t. And what this is the negative of 2 to the t plus 1. This is accounting for all of the transformations except for this one in red right here. I'm not done. I just wanted to draw this as an intermediate step so that I'm not applying all 3 transformations at once, because I thought that might be confusing to people. So now what I'm going to do is I'm going to take this dotted line and I'm going to transform that one more time. I'm going to apply my horizontal stretch. In other words, I'm going to take all the old x coordinates and divide them by -1. This x coordinate is -4. -4 divided by -1 is +4. So he ends up over there. This x coordinate is 0. 0 divided by -1 is 0. So it stays right there. This x coordinate is 2. 2 divided by -1 is -2. It goes over here. And what I end up with for my final answer, it's hard to go through the dots. Connect these guys with the curve that you're trying your best to resemble this immediate graph, this original graph. I'm going to try one more time. Kind of want this a little steeper over on this side. And then it turns out that maybe I'm getting a little too picky here, but I want asymptotic behavior here. Just like this graph never quite gets to 0, but gets closer and closer and closer. When I did all my vertical transformations, I changed it so it never quite gets to 1, but gets closer and closer and closer. So I want this to never quite get to a height of 1, but get really, really close. This graph right here would be my final answer. Probably should be labeled in blue. You could argue that it should have been drawn in blue. There you go. Now it's drawn in blue, and I'll call it k of t. And I suppose that would be the answer to the problem.